Hello and welcome back. In this video, we're going to be learning how to convert fractions into decimals. I have a couple different fractions written up on the screen, and we're going to convert each of these to decimals after we learn what a decimal exactly is. So, what is a decimal? It's basically another way to express the concept of a fraction just in a different way. So, for 1/2, fractions are essentially like mini division problems. So we can think of 1/2 as being the problem 1 divided by 2. For decimals, it's the same way. It's also expressing the same concept, but when you write it, it looks more like a number followed by parts of a number. So for example, the decimal corresponding to the fraction 1/2 is 0.5. And this is the case because the number on the left of the dot represents whole numbers, so like 0 here. And then later on, when you see mixed fractions, like 1 and 1/2, you'll see like the 1 on this side. Then comes the dot, which signifies parts. And so what comes after the dot is numbers representing the parts that aren't like whole numbers. So when we do that, decimals are called, they're based off a system called base 10, which just means that we calculate everything in relation to the number 10. So the complicated way to explain this is that the number to the right of the dot, here we have a 5, right? And the reason why we have 5 after the dot for 1/2 is because 5 is 1/2 of 10. So it's kind of weird because to understand the decimal, you actually have to understand fractions. Which is maybe a little bit, it's a little bit circular, but this is why you learn fractions before you learn decimals. So hopefully that makes sense. So what's left of the dot is the whole number, and what's right of the dot is numbers that represent the fraction, but with taking the fraction of the number 10. So 1/2 of 10 is 5, and that goes here. Let's continue with this example. So 2/5. Again, the corresponding decimal to this fraction is going to have a 0 on the right because it's less than 1, and it doesn't reach a whole full number yet. So what comes on the right? So what is 2/5 of 10? Well, when you multiply 2/5 times 10, you're going to get 4. So actually, 2/5 is 0.4. These are the same. This is the decimal form of 2/5. Now let's move on to the next one, 3/10. So again, not yet 1, so we have 0 point. And remember, the point is like the border between whole numbers and parts. Okay, and now for the right side of the dot, we're going to do what's 3/10 of 10 again. So that's 3. So it's actually 0.3 is the decimal for 3/10. All right, and then we have 1 and 1/2. So now we have finally exceeded the number 1. So now we're gonna have 1 on the left side. And after we write that 1, we can actually forget about it. So let's just worry about the parts on this side. We cover all of the whole numbers on this side, and then only the parts to the right of the dot. So 1/2 we already know is 0.5. So since we put the 1 here, we're just going to put the 5 right here. So 1 and 1/2 is 1.5. Next one, 2 and 3/4. The 2 is going to go on the left, then the dot, then we have 3/4. What is 3/4 times 10? So let's do this on the side. Okay, so when we simplify this, right, this is 5, this becomes 2, and now we have 3/2 times 5, and when we multiply that out, we have 15 divided by 2, right? So we can't do that still. How do we express this? So when you actually do the division problem, like 15 divided by 2, instead of just leaving it as an improper fraction, what is 15 divided by 2? Well, there's going to be a remainder because it doesn't divide equally. But you could also think about it as like, since we don't have to do remainders anymore, let's try dividing with like a fraction, like so we get an exact answer instead of a remainder. So 15 divided by 2 is 7. So 7 times 2 is 14. We have this 1 left over. And so what is 1 divided by 2? Well, it's just 1/2, isn't it? So why don't we convert this to a decimal? So when this becomes a decimal, this is 7.5, the 5 coming from what we did in the first problem. So now we have this 7.5 here. This is the number that's going to go to the right of the dot, but we're not going to bring the dot over. We're just going to write 7, 5. And when you see how that it works like that, because again, since it's base 10, we can think about it as basically we will take the same numbers, but the dot doesn't matter because we could honestly multiply it by 10, 100, 1000. It could be it's the same thing. What we're concerned about is the digits of the answer that actually have numbers in them. Because think about it, if we did this again with, let's say 100, right? Taking it out of 100. Again, base 10 means that we don't care, or all that matters is that like it's like 10 or multiples of 10. So not multiples, sorry, squares of 10. So just keep adding zeros basically. So if we did this problem, right? We cross this out, this is 25, and this is 1, because we divide both by 4. 3 times 25 is 75. This is what we wrote here, just without the dot. This is a surefire way to do it if you didn't want to do it this way. But in the end, you get the same answer. And again, the reason why you can ignore the dot when you're just calculating the right side of your decimal is because, again, it's base 10. And all we care about is the numbers. And then if you make this, instead of 100, if you make it bigger than that, make it 1000, you're going to end up with more zeros in this answer. But let's say you wanted to put all of that in, right? So you'd put like 75 like this. This is irrelevant. Like in decimals, when you have zeros at the end of the decimal, as in after all of the numbers, they don't count at all. It's like the same thing, but it's just unnecessary to write that many zeros. All right. The more we practice these, the more you'll get used to seeing them and how they work. Let's try the next problem. 21 divided by 10. 21 over 10. So first, it's a good idea to convert this to a mixed fraction. So as a mixed fraction, this is 2 and 1/10. Now let's convert this to a decimal. So it's going to be 2.1/10 times 10 is just 1. 2.1 is our answer. And we have one more problem, 37 over 5. Again, let's try to convert to a mixed fraction. So the closest we can do is 7 and 2/5. And so our decimal is going to be 7 point. Then we do 2/5 times 10. And when we multiply that out, we get 4. Well, we did this over here, so 4 is the right side. And that concludes our practice for converting fractions into decimals. Thanks for listening, and see you next time.